I'm here with scientist Dr. Tess Little, and we've been having fascinating conversations off camera. The one is on the memory of water and the whole controversy and the attack on homeopathy as one of the reasons why it can't possibly work, because water cannot retain memory. And I've done research on Benevist's work and I've discussed it with Tess, and she's come up with some fascinating answers. So I invited her here to please share your work. Welcome back.
Thank you very much. I enjoyed our conversation, and I myself have looked into the papers and the publications. There's been two with regards to that work, yes. And I have a personal interest in EM fields, and with biophysics, it's good to try and look at it from a scientific perspective. Do we have a mechanism to describe the memory of water and what they're saying that's possible? And I do enjoy looking at homeopathy. I have seen personal results amongst my friends.
This is so much more than homeopathy, though. This is a very scientific look at the capacity of water to retain memory.
Sure. But that also brings in a whole lot of questions is, what is memory?
Yes.
I mean, first of all, we don't even understand yet in the brain how we hold memory. We've looked at various mechanisms to explain that, and we still do not understand that. And also, in terms of a scientist's perspective, if you go into biophysics or physics, what is time? Okay? So when we start talking about the memory of water, what actually are we trying to look at? And from a human perspective, we look at it the way we experience life. And our best way of doing it is saying, okay, we understand time. We get this experience of the future and in the past. So in many ways, let's look at water in terms of its memory. Okay, is it able to hold a stable structure for over time? And what in there can do that? And also the question is, can we imprint just with our minds, with fields on water? Is that possible? And what mechanisms could explain things? So for me, it's been an exploration of looking into electromagnetic fields. And then we talk about light and its effect on water. And in this experiment that they do, they are able to claim to have received or be able to pick up an electromagnetic field. Now,
can I interrupt you here? Why are you talking about electromagnetic field, and who are they?
Benevista's work, in experimental work, sorry.
Right.
I'm speaking about electromagnetic fields is because that's actually the construct of the experiment. Now, we often in science refer to electromagnetic fields, but very often in the general population, people refer as light as not being part of electromagnetic fields, not having that understanding. And it's very important for people to understand there is. Actually, light that we see is actually electromagnetic. Now, light has a property in which it can entangle information. And there has been scientific experiments done in the past we know about called the double slit beam experiment. And this is all very, very important, because then we can start understanding there could be a mechanism in physics to explain how we are able to impart information and extract information from molecules, not only just water, that is at a quantum level. If that is possible, then these things are possible. Then now we're talking about things that can occur at long distances, that are non-local. And all of these things are important when we start looking at these mechanisms.
So that's quantum physics.
It is quantum physics, quantum mechanics. I'll be very specific about
What's
that.
the difference?
A lot of people speak about physics generally, but from my understanding is when we go into theoretical physics, it's more mathematics and less of experimental data, whereas quantum mechanics is actually determining information and trying to understand that information from experiments. So it's got a theoretical and practical application. And we are explaining the mechanisms of chemistry and what we are doing with the technology. So I'm more in favor of spending time in that area, in that field. And when we start doing like CERN and those experiments, that's more particle physics, that's a different field. So going back to the memory of water, we have certain things that are separate in their studies. We've understood that water can form a structure, it is stable. And what does that actually look like? And Pollock's work has contributed significantly to this area. Emoto's work, referring to there's a possibility our minds something around
Mm-hmm.
us is imprinting on water. So these do open questions. Are there many scientists in this field? Not so much.
It's a pity.
It's because it can threaten a person's career, because we're going into a field that has got this negative notion, and Ben Vista unfortunately got heavily nailed for his work.
He did.
And it is controversial.
Mm.
Though there are some people who are now willing, scientists who are willing to explore this area. So looking into their papers, some of the mechanisms are difficult to right now say that is plausible. It's a nice theory to work on. But we are getting results in... I just want to explain something. Some of their research in this was to use DNA as a way of showing that information between DNA and water can occur.
Okay, not talking DNA memory.
I would really just say it's this communication, but memory in terms of the device, the information, the field, can be stored on a computer and then sent off to another computer and downloaded back into water as information.
Okay.
And they were successful. They claimed to be successful at that. Obviously, we need more people doing this work at the level of receiving information, understanding what that looks like, and then re-imprinting. And not just using one form of DNA. In that particular experiment, they used HIV DNA, which is in itself unique.
Sure.
So there's many things that we have to look at and break it down, but it doesn't mean it's not possible. It just means we need to look at it from a new perspective and take into account what we already know.